So, thank you.
All from where? Norway. Oslo, Norway. Later on, when Helga moved back from the United States, moved back to Norway, he did his best to try to teach me how to downhill ski on the icy slopes of Norwegian mountains. But I'm a Southern California boy who grew up on surfboards and waves in the ocean, and skis didn't fit very well on my feet. Well, I hand it to Helga for trying to give me an indication of what it's like to enjoy the Norwegian winters. So, monitoring air pollution led to the invention of new kinds of lasers. The industry in this area, lightwave electronics, new focus, spectral diode labs. They were supported by the national labs in the area, and of course supported by students educated at Stanford University. Kurt Weingartner and his wife Ursula Keller were co-founders of Time Bandwidth Products in Zurich, Switzerland. And here's a photograph of our reunion last year, where some 200 former students, PhDs, came back to the Ginston Laboratory. Silicon Valley today remains Hewlett-Packard. It's a giant relative to other companies. These numbers are about 3 years out of date, so just take them as relative numbers, not absolute. The valley today is not a $360 billion a year valley. That's 2006 number. It's $1.5 trillion annual revenue stream in Silicon Valley. That's a significant amount of annual revenue. But 150 of the largest companies in Silicon Valley control or generate most of that revenue stream. There are a lot of small companies in this valley with 20 or less employees. And a lot of those companies are not successful once they're started. And the numbers I like to use, it's typically about 1 in 10 of these startup companies actually make it and do well. And about 5 out of the 10 hang on and go into a mode we often call a living death mode. And then there's another 4 guides and other such information. It's there on the internet for those who want to learn the details. Let's move now to Silicon Valley and factors. You transferred technology from Stanford to Silicon Valley. Your inventions at Stanford led to the growth of Silicon Valley. In the Dean of Research office in 1989, when I served in that office, we asked the question, how many companies use Stanford technology, either directly or indirectly? And we hired some help over the summer to go out, and the answer came back that less than 1 in 20 used Stanford technology either directly or indirectly. Then why were they located here? Why did the startup phenomena start here? It's because they had access to educated men and women. So our contribution to Silicon Valley is educated students. That's the fact. And if you would want to start at Silicon Valley in Norway, perhaps at Fornebu Airport outside of Oslo, it's educated students that are going to make it happen, not technology. So here are the factors for success. I made this slide up probably 20 years ago or more now. Entrepreneurial attitude counts for a lot. Educated people, land resources, around the world. That was a question we asked in the mid-1990s. And I began to get invitations to give talks in various parts of the world about the phenomena called Silicon Valley. Quebec, Canada was the first talk that I gave. And then notice there was Oslo, Norway in 1997. Going back and visiting friends in Norway again. Barcelona, Spain, 2001. They acted on it, and Barcelona has a very active technology infrastructure now outside of Barcelona. I put your Silicon Valley phenomena adapt to the local economy and the local conditions. And if you do that, you can indeed create Silicon Valleys around the world. And we know that now because we have many examples of regions of the world that have created technology infrastructure and technology economy in their local area. From Munich to Japan and near Kyoto, Kobe, Japan has become a way also where there are Silicon Valleys that exist today. Now let's move on to the interface, Stanford and the interface, working in photonics and lasers and optics at Stanford. So here's an example of companies that have helped support our work. We support them by providing education. Director of OTL, now I have brought with me my pocket laser, and there's Kathy right there. So my green laser is both a combination of a diode pump solid state laser and nonlinear optics. Thank you for using those words. Okay, there are inventors at Stanford campus, and we can celebrate them. Richard Zaire, chair of chemistry until this year. I'm someone who dreams about making revolutionary changes in the world through science. Microscopes, Gordon Kino of getting that technology where it counted into the commerce stream. So Office of Technology and Licensing, and the UC system with its 7 campuses outstripped Stanford easily. Columbia did very well because of their medical school, and Stanford is no slouch when it comes to getting technology out into the commercial stream. Our students at risk. We had to figure out, could Stanford invest in small companies, and if so, under what conditions? Could we take an equity position in a Google, for example? And if we did that, how could we assure that the university would be a disinterested party and maintain its independence? And finally, could our faculty be involved in aspects of its mission to educate students and to gain and apply knowledge through research and innovation? We are an institution of public trust. Of cash from small startup companies, but the way the equity is distributed and the way it's handled was prescribed quite carefully to make sure, again, that we avoid conflict situations. And finally, we have a conflict of commitment that Stanford faculty review once a year, and the very top phrase is the one that I like the best in this policy. Stanford faculty members owe their primary professional allegiance to the university. With that in mind, I think we've seen these policies now exercised for the last 20 years, and they seem to have worked relatively well. On occasion, we have to establish sort of independent committees to go investigate and make sure that faculty and students and staff at the university are abiding by policies. But by and large, it's been self-policed to a very high degree. Let me finally conclude. Global economic growth is driven now by technology, by knowledge, by communication. We're one planet at this point, and we've changed our paradigm of how you create and manage wealth in the last 100 years. Our goal in the university is to maintain our commitment to teaching our next generation of students and to generate new and apply new knowledge when we can. I think we follow what Senator Stanford had in mind when he created Stanford 110 years ago. It takes time for technologies to migrate into our social milieu and to our social well-being. And I like this slide from Forbes magazine. I tell my students that Forbes Science Writer was one of my favorites. It takes almost a century for major change to occur in society. The introduction of the railroad, the introduction of airplanes, electrification. Those are things that take time. In the modern world, things seem to be happening more rapidly, and that's because we're building on the base of these earlier technologies. The introduction of lasers into our manufacturing systems came about in 50 years, not 100 years, because we were already electrified, we were already automated in many ways. So let me close by just reminding you that the world is changing as we speak. This slide was produced in 2004, 6 years ago. And roughly speaking, 1/3 of the research and development was being done in North America, about 1/3 was being done in Europe, and about at that time, about 1/3 was being done in Asia. And at that time, I made a prediction that somewhere 20 years in the future, 1/4 of the research would be in the US, and 1/4 would be in Europe, and 1/2 would be conducted in Asia. I was wrong. It wasn't 20 years, it was 10 years. So within a decade, this graph is now the truth. So what does it tell us that we have to think about? We must do this research and development and application of these ideas in a collaborative way on a global scale. That we all need to take advantage of the knowledge gained in the fundamental research environment, and we need to find ways to apply it in a collaborative way on a global scale. With that, I'll close with just one statement on where lasers are going in your future. 45 miles in that direction across the bay. To the west is the National Laboratory, called the Livermore National Laboratory. They have the world's largest laser. That large laser is now illuminating targets that are about 1 millimeter in diameter. Those targets are filled with hydrogen and deuterium. And when they are illuminated by the laser, they are squeezed to a temperature that matches the inside of the sun. And for a very short time, we do laser-induced fusion. And we generate a small amount of energy right now, but the goal at the end of this year, by the end of 2012, 1 year from today, the goal is to generate laser fusion at a break-even burn. That is, we put in 1 megajoule of laser energy not be laser fusion energy. I think we'll drop the word fusion and people will just call it laser energy. Thank you very much.
So most people, when it comes to lasers, connect lasers to laser surgeries. But there must be more with lasers, and they must be used in more ways than just laser surgeries.
So lasers are used quite widely, but medicine is what most people know. And so, but lasers are also used to manufacture your automobile. And of course, lasers are used for all of the communication that you use on the internet, on your cell phones, are all driven by lasers in a fiber.
And what is the biggest revolution when it comes to laser development? If you look back nowadays...
The biggest revolution in laser development, they've become more efficient and they become ubiquitous. Lasers are everywhere in your life and you just don't know it.
Where exactly in our lives that we don't know about?
You have a laser in your car playing your music, you have a laser in your home, you have lasers when your cell phone works because it transmits the signals that go by lasers through optical fibers to communicate. So these are examples.
And what comes after laser then?
Okay, so in 2009, 2 years ago, we entered the age of X-ray lasers. So today we have lasers that are operating in the X-ray range, and they're going to be used not only for imaging bodies, which we know X-rays do, but for studying nature in the finest detail. We can actually now watch an atom tick in its own time using X-ray lasers.
And what are the hottest topics in technology nowadays?
There are a lot of topics in technology which include communication technology, social networking, things we heard about at the meeting here this morning. In laser technology, it's really inventing lasers that are efficient. It could be used to manufacture computers, they can manufacture cell phones, and do so at a lower and lower cost, so we all benefit from that.
Are they already in use, I mean, those technologies, or are they being developed?
Every time you pull out a cell phone, the laser has been used to manufacture that cell phone. From the electronic circuits in the cell phone to cutting the glass that makes up the faceplate is all done with lasers.